Hello, everybody. In this video, we're going to talk about one very important feature in Aspen Plus, which is kind of very useful. We use it a lot to kind of adjust some variables that we cannot adjust accurately manually. And this is, for instance, let's say if we take a look at this the mixer and the results of the mixer. We used just a simple mixer, and in this case we had moles of each one of these, or the mole flows of each one of these components, in kilomoles per hour, and this is the second stream to be mixed, and this is the product. And from this we can see that this is the sum of these two, and this is directly dependent on the flows of the two streams. We can find also the mole fractions from here. We know that this is 7%, this is 71%, and almost 21.4%. So this is kind of totally understood. But in some cases, you might need to manipulate one of the variables so that you can adjust a specific parameter that you want to keep at a specific value. For instance, I want to change the mole flow of ethanol in the feed so that the ethanol in the product is 50%. The mole fraction is 50%. Anything. I mean, just think of any variable that you want to adjust so that you can adjust another, or vary so that you can adjust another variable. And this happens a lot in many cases, such as the heat exchangers or coolers or heaters. You might be interested in adjusting the flow rate of one of the two streams so that you can get the output stream of the outlet of the other stream to be at certain temperature. So it needs kind of iterations and some calculations that require some trials. And we can see that directly, that if I change I have here the ethanol in the feed is, I think we use the mass flows. Yeah, it is 10 kilograms per hour. So in the feed, if I change the F1 instead of 10 to like 50, and we have still here the stream results as we checked last time. And these are the mass flows, and these are the mole fractions. Still, I didn't do the run, so this value is still at the previous value, but I'm gonna go do the run now, and the values should change. And this is 50 now instead of the 10 that was before. And in the mole fractions, I see that this value increased. It was 7%, now it's 19%. So I understand that I need to increase the value of ethanol in the feed so that I can set this value to 0.5. But again, this will require a lot of iterations and a lot of trials. And Aspen Plus can help me do this without doing this myself. Before going into the details, we just want to keep in mind, or think of what inputs should I give to Aspen Plus. I should define the variable that I'm going to manipulate, which is the flow rate of ethanol in the feed. And I want to define the target, which is the ethanol in the product, the mole fraction of ethanol in the product. And I want to define the value. I want this to be equal 0.5. Of course, this is a simple problem, but it's applicable for anything. You can apply it for distillation columns. You can apply it for heaters. You can even apply it for streams of different parts of the flow sheet. So in case you have, for instance, a feed stream and then passes by heater, then reactor, then flash separator, then you can change the change the parameter in the feed, maybe temperature, maybe pressure, so that the very last stream can be adjusted. This is something that you can easily do. But again, I just want you to keep in mind that I have to define the manipulated variable, the product, or the target variable, or the variable of interest, and the target that you want to achieve. And the place where we do this is in the flow sheeting options. We talked about it quickly before, but we will go into details of this now. And this is called design specs. If we go to the design specs, we can see that there is nothing here. We need to create a new design spec. I would call it DS1, just keep it as it is. And here you'd see that there are three tabs that are or that need inputs, which is the define, this is the spec, and the vary. Um, one kind of thing that makes some people or makes it not easy to do is that we don't understand where we put the inputs. And this is why I mentioned before that there are three things that we need to define, and this is where we would put the three things. The define, it says the sampled variable, and the sample variable is the variable of interest, which is in our case the mole fraction of ethanol in the product stream. And the spec is the value, what is the value, the 50% that I mentioned before, and the vary is the manipulated variable, the variable that you're gonna change. So I'm gonna fill it one by one, and then we will see how we can get this done. So again, I don't have anything here, so I have to create a new variable. I'm gonna call it um, the ethanol fraction. Okay, um, and the way we define this is kind of not very straightforward. You have to go as the software requires. So it asks you first, what is the category of this variable? Is it a block variable? So it's a property that is related to the block itself, or it is a stream variable that's related to stream. It's a model utility, property parameters, or reactions. In our case, it's a stream variable. And once you select this, the list here shows you all the parameters that relate to streams. So we have here, there are some parameters here that I'm not familiar with. Let's say this is the, I don't understand this actually. This is the component attribute at one time and associated with the Fortran array. So this is uh, something that it's a user defined. So you can go to this tab, and then you can write a code using Fortran language, and then you can define it here. But I'm not using Fortran now. I need a simple parameter. Maybe we can go to Fortran later, but at this time we are not using it. We want to change or adjust the mole fraction, okay, of the product stream, of the component which is ethanol. So now it's well defined. I don't need to define anything else. And here I can set what is the value. One thing that I would expect myself is that the value would be in the same place. So I can have like one more column here and say the ethanol fraction to be 0.5, but this is not the way it works. You have to take this name as it is. I usually like to copy it because if it's not the same spelling, it's not gonna understand it. So I'm gonna put this as the spec. The target is 0.5, and the tolerance. The tolerance is how much error is acceptable. So if I want it to be very, very accurate, I'm gonna make it 0.0001. This means that it can accept a value of 0.4999, and this is a solution to Aspen Plus. I personally do not like to have this variable very small, or the tolerance to be very small in cases of having big flow sheet, because in some cases it's not very easy to reach this tolerance. So it might reach a solution, which is a good solution, but the way you define the tolerance will not make the solution acceptable. So it might tell you that it didn't match your requirements because the tolerance is very, very small. And the last tab is the vary. What is the variable that you want to change? I want to change, you'll have here a very, very long list of variables. So it's balance variable, or it again before going into this, it's very common to have like or take some time to search for the right variable. You can try one and then you find it's not the right one, then you try another one. It's totally fine, it's totally acceptable, and it takes sometimes for the user to get used to the way of looking for the variables that he wants. So there are block variables, there are chemistry variables. Again, there are some Fortran related things. But the one I'm interested in is the stream variable. And in the stream variable is, I'm gonna make it, I think this is not the right way to do this, but I'm gonna try it and just to show you that it might not work. The first thing that you jump into your mind is the stream variable, and then you can make it the mass flow of the ethanol in the feed. This is the variable I'm interested in. But what you'd see here that it didn't ask you what component. And this is because the flow rate is the total stream flow rate. But this is not what I'm looking for. I'm looking for the component flow rate. So it is not the stream variable, it's going to be the molar flow or the mass flow. We want the mass flow, and here it's going to ask you for the component. And this is one thing I learned by trial. You tried something, you found that it's not the thing that you're looking for, and then you try something else. And this is how it works. And then these are the limits of the manipulated variables. I'm gonna put it from 50, and this is the range that's gonna change the values from 50 to 500, for instance. And then everything is ready. And once you run the file, it's gonna run everything. Again, just keep in mind that I have already some inputs, and there are some results in here that are based on the inputs that I put in the very beginning. So these are the mass flows, and these are the mole fractions. It's 50 here. I just want you to keep in mind that this is 50. And once I run the file, I didn't change the input here, but what you'd see here that the ethanol change, and this is because of the design spec that I put. And when you see here, this is 0.49997. Again, this is the tolerance, so it sees this as 0.5. One thing I can do if you want very, very accurate results to make it like 0, and then run the simulation. And in this case, it usually gives an error because it will never be able to get the exact value. And this is what I told you. It already had the solution. The final is 0.4997, but I told it that it has to be exactly 0.5. So I can make it like more accurate. It should give a result now. And from the results it sees it's 0.4, it's almost 0.5. This is the result that we got. And again, if we check the stream results, these are the mole fractions. It's exactly 0.5 now. And these are the mass flows. It's 239.286. So this is kind of very, very useful things. In the results, you wouldn't expect a lot of information, just the manipulated variable and the variable of interest and the initial values and the final values. Again, here in the inputs, you'd see that it still keeps the input that you put in the beginning and then changes the value based on the design spec. So it doesn't change here in the input, but it changes in the results. So you see here in the results, for the mass flows, it's not 50, it's 239. So this is a very, very useful tool in Aspen Plus. And I hope it's useful, and I'll see you in the next video, inshallah. Goodbye.